right, welcome back to the conference. I'm very happy to introduce the next talk of track 1. On his LinkedIn page, it says he's a JavaScript addict and a software architecture maniac. Welcome, Dmitriy Shekhovtsov. Welcome on stage. But he's also a guru developer expert, actually, in web technologies and Angular. He contributed significantly to projects such as Angular, TypeScript, NX, RSpec. He's the founder and CEO of Valor Software, where he and his team have authored numerous open source projects, open source libraries. So thanks for all the hard work you've put into these projects. Also the co-founder and CTO of Zephyr Cloud. And today he will talk about modern development strategies and the tooling needed to move at the speed of thought, which is also the title of his talk. Basically when developing micro frontend applications, of course, and he will also show practical solutions for the biggest issues with such applications. So without further ado, I would say, Dmitry, the stage is yours.
Awesome. Thank you for your introduction. It's actually a pleasure to speak at your conference. So I could skip most part of my self-introduction thanks to you, but definitely we're going to speak about moving at the speed of thought when you develop your applications. So everything about me you already heard from our host. So getting to the topic. In terms of the performance and perception of the speed, we are as engineers have a different perceptions of what speed is. Like we cannot agree on what done is, and like we want to discuss what is performance or speed of thought or how to quickly develop things, right? So yes, it may sound as an unrelated question, but before we go into conversation about performance, things to keep in mind while we are going through the slides is why we can commit and push on Friday evening or even on the weekends, but cannot do the same for our deployments, right? So that's something to keep on the background when we are speaking about performance too, because that's in a nutshell will be part of the answer of not only how to move fast with your thoughts and your code to deployment to production whatsoever, but why we can do that. And reason is like performance for this conversation would be how much time it takes your code to hit production. If I do the change on my local machine right now, I do commit, I do push, and how much time gonna be there in between of my push and when it actually gonna land to production. I do believe that answer will be very, very different, depends on how do you work. If you do, I don't know, FTP to PHP server, that's gonna be instant change most likely, right? But if you speak about like modern development, most likely you're using a lot of things in between, like your local quality gate checks, your CI/CD quality checks, code review, human interaction, some time spent on that. Then we're going to have one more production build, one more testing, one more end-to-end, one more deployment. If there are any issues, it goes back. And that time can take somewhere, usually in between, from a day to weeks or even a month, right? Which is kind of not very close to moving fast or delivering your changes or delivering your code are performant, right? So even if you like hit your local builds under a second and like you reduce the time spent on CI from hours to minutes or like whatever, it's still going to spend a considerable amount of time to hit the production. So what potentially we can do about that? And I will try to show a very small demo just to give it a small glimpse of how that's potentially may be. And of course, what kind of model federation without tractor sample. We will go to not so pretty thing, but very, very fast. So for me here, I'm super lazy engineer. I'm just hit build and going to do something. And what it does in the background, it actually deploys this application to version environment. And all of that was done quite around a second. We can try to change this wording, hit again to see how that's going to work. And let's do that in a simpler way, maybe. Or not. When you hit development, the good thing about it is it's at least it's not works just on my machine. It's actually available on any of your environments. Okay, I will go to sampler. I will do another way. Let's build quick. Whatever works the same way. Just hit build. Just waited for it being deployed. Okay, all of that's deployed. Let's go here and see that our deployment to this one took around like a second, because we was updating a lot of new assets, and for some reason this tool doesn't like me today. So I'll just skip the part of looking for for the text. And well, I was like, okay, let's try another one. And this one just error-spark. Whatsoever, I can build deploy it under a second for all day long now. Yes, finally, something I'm working a lot with. So I'm going here, and let's say that we are finally found the sample, which we are going to deploy to productions one and more again, and our moving with the sort of light, moving fast. And all I need to do is to hit the build again. And there are a lot of things interesting here, which is kind of internal, not super important, but even my mistakes going to hit and will be in the history now, because each deployment creates something. The fun part about it is how much time I have to spend on configuration for this part, and the only thing for configuration for these deployments and provision environment is pretty much just a one-liner, right? So this is not in a nutshell how your deployment may look like. You don't do CI, you don't do other things around. What you do is you do build, and that build actually hits production or some version. So the main question is here is it nuts as it sounds that any of my code changes after the build are deployed? Let's figure it out that together. So in terms of like micro frontends and model federation in particular, that's kind of an old slide. I suppose there are more websites which are already using it, but there are a huge amount of engineers, huge amount of websites, web applications, whatsoever, already benefiting from model federation. It means that whatever we are discussing here applies not only to a particular solution, but that applies to a lot of people who may potentially use the benefits of moving with a sort of speed. Up here, I mean that your build time and deployment time are similar, and you don't have to wait for days, hours, or weeks in between when you potentially may look on your code change, deliver it to production-like environment. So, and in order to understand why, we can actually skip a huge part of the things which we are kind of get used to work with, which is like 10 years ago wasn't even a thing, but now we are seamlessly want to follow it. We don't want to break it. We want to kind of go through the code, through the build, through the tests, through the CIs, through the code review, then release, then deploy, then make it operate, monitor the changes, and then repeat it again. And all that takes a huge amount of time. And there are such important things, especially for your managers whatsoever, is tied to market, which is kind of sounds great, but for me as engineer, is more important to increment faster, and developer experience in general mean that if you have like 3 4 hour builds or nightly builds, which some people most likely have seen in their lives, that's an awful way to see how your changes actually affect um, your application. Now we're at the stage of engineering when we are kind of have a super fast builds, we have a lot of tooling around developer experience on your local machine, but still operate in terms when we have to wait for considerable amount of time in order to push it forward. We're gonna skip the planning phase of the cycle, which is kind of start. Nobody can actually do that. So we have a chat GTP to ask whatever we should do today, and even ask for parts of code. And we will see how currently what developer experience tools are doing for making your coding, or what kind of practices for code build and tests already on the market, and what we can introduce for release deploy, or how we can kind of hack the cycle in order to move with the speed of thought. So at a build stage, that's not an advertisement. I am not affiliate of Nextcloud, but I'm a very a fan of this tool, which helps you a lot. There are similar things like Bazel, like Turbo Repo, and some like Rush or some others, which are providing similar functionality. But main idea is here that whenever you do kind of build of particular commit, I would say, it's able to cache those things to the cloud, and whoever else repeat that build or actual test or whatsoever will be able to save a time on not rebuilding the things again, which is kind of good concept based on centralized caching of results. So you're pretty much caching of what you have on input and what you're gonna have on output, and being able to reuse that information to speed up your local or CI builds or whatsoever. Obviously, before this and in parallel to this one, we do understand the larger the code base is, the slower the builds are. So splitting your kind of your micro frontends conference, so splitting your monolith application into smaller parts, into modular system or federated applications, obviously gonna reduce the amount of code which you have to build at once, but meaning that it's gonna speed up the way how fast it's gonna be built, right? And on top of that, we may introduce tooling like Nix or similar in order to move even faster, to reduce the time from seconds to milliseconds, which are going to help you to improve and move faster. After code and build, obviously, we're going to discuss release and deployment, which are oftentimes used as a one thing, while in a nutshell, especially for library engineers, whatever, we speak about that release is potentially for humans when we are was working on a chunk of functionality of fixes whatsoever, and we have a human readable pretty much description and version and time and contributor list of who was working on the release, and we are preparing the chunk kind of code and a description for it to being deployed, while deployment is pretty much to make this new version of your application to work on desired environment. That's usually doesn't really make sense to have a difference in between of those, but for our conversation, that's gonna make some sense. After we have our code on deployed, it operates, right? When we are deployed at a particular environment, it starts to operate, meaning that it's running up there, going to live, and then we are able to monitor. And when we monitor, we mean like we can use Sentry, Google Analytics, and any login whatsoever in order to understand how our application is actually performing on the desired environment. So looking into this, right? That's just another perception on SDLC. What we was not discussing, that in between of code build tests, we're gonna repeat that same stuff again on CI, most likely several times for each of your commit, then for each branch, then for each merge, and for different environments where it's going to be deployed. Even if it's deployed and we have some kind of like have to do rollbacks or fixes, whatever, we have to repeat the same parts of this life cycle over and over again, which is completely not a bad thing, especially taking into account that most of the parts are automated. But our conversation is about the performance which you may achieve and getting from your code and build into deploy, not throwing away all of the other parts like continuous integration or deployment, but potentially being able to view your code changes in production environments immediately to make it operate and actually monitor. So this is a super important question of how we can achieve that. We'll try to decompose SDLC into common terms which are familiar to most of us, and that will make easier to um, get to concept that while we are speaking about deployment, the things improvement to deployment process, the things which are we're using daily and exist there, that's something we should have used for federated applications for a while and for deployment in particular. So for a code, you can see that I'm not very good at cleaning subheaders. For a code itself, for storage and for distribution of using Git or GitHub, which is kind of distributed version control systems. And the most important part here is to understand how, for example, Git works, and that we have a Git flow, we have commits, which are kind of immutable set of changes, which has a particular version, right? How Git works, how it actually pushes the code to Git server. And what is most important, we don't really care in most cases where that Git server is actually located. Because after the clone, we don't really think that if we need to create a branch, how are we going to orchestrate that branch on a Git server, right? So all we do is we actually doing the code changes, then we do a commit, and then pushing those changes to actually server, which now our code changes are served on the particular server. So it's starting to operate. In terms of package manager, is super important for us that people who are from older days remember things like buffer, remembering things like jQuery source code, which was committed to your repository, and some particular people who was fixing jQuery issues in your local copy of a library, which is committed to your branch, and particular results fixes making your kind of stuck into a particular version of the library which you use. And this is really was a quality step moving forward when we moved into more centralized way. When we have an npm, we have like a name of library and a version. We don't really care where it's hosted, and we just can, through the name resolution, through the package manager, get the proper version and start to work with that, right? Of course, tools like AI, which became our third hand into development, became in particular important. You don't even realize how many people actually using that when things like ChatGPT goes down for half a day and your Twitter just exploded. People aren't able to work anymore. Moving into just highlighting some parts from Git, which I didn't spoke before, is whenever the model of deployment to Git server, which we are not using for deployments of our build application, is uploading only changed files. So if to look how Git works internally, whenever you do a change to your files, you can of course take a look on what has been changed, but Git actually doesn't load the difference. So it doesn't use computation later on to understand what has been changed. It actually has a copy of each file which has been changed, and then you're able to compare that across versions, close sibling version or remote branch versions quite easy, because Git is able to reproduce the state of your repository based on files which has been changed. And that's super important for incremental work with Git, because like you don't spend a lot of time, especially when you have huge repositories. You don't upload each time 100 megabytes of code each time you do a Git commit, because it would take a considerable amount of time. But on the other hand, that's what we do for each deployment when it does or doesn't actually makes any sense. In terms of what Git as a process gives to us is being able to check out a particular version, being able to roll back to a particular version very fast, like super fast Git checkout on a local machine for a particular version, or checking out for to master and pushing that it's seconds or sub-seconds. That's in particular making like a standard for what should mean moving with the speed of thought. If you speak about like Git, that's a sub-second to do. And because how Git works, in most cases, you feel safe when you are able to do things like commit and push and all of that daily routine. You don't really scared to git push to the Git branch if it's not master, which have continuous deployment on the Friday evenings, and knew exactly that everything's going to be fine and nothing going to break, which we don't have with the deployment. For Git flow, this is just a map of things to keep in mind, that while our understanding of the code base itself is not a snapshot, right? It's not linear. It's not like just linear events of time. That's work which is done by a team in parallel. And that's a model how our brain works when we do perceive the code base itself. And we're going to get back to this thing, because that's something our brain is already, how it works already, and what it brings for our understanding as engineers in order to move forward. So if as of package managers like npm, esm, or kind of over, just for a joke here, I suppose it discontinued for a while, but we do understand, so no matter how many times we are going to check out a particular version, by name a version of the library, we're going to check it out the same thing. So our expectation for developer experience of engineers, that particular version is immutable, and that the version has a particular structure, and there are logic behind of the three or more numbers in assembler, right? We do expect that we are writing our packages in file or using CLI tool to resolve particular name in a version into something, into actual library source code that is going to behave as expected. We cannot say the same about when we do configure our model federation configuration or any other federated model federation implementations for the UI. Whenever we point to some other federated or remote application, that what we're going to get is going to be versioned or going to be same thing each time we pull, which unfortunately not a thing, and put us in danger that our application going to break because somebody has updated the application itself. So pretty much we always look in a particular or several URLs in order to pull whatever latest there without any particular control or safety, obviously, which makes us less self-confident in what we do. In terms of package manager, what is important to discuss is the pretty much settled down process of releasing a new version. There are some tooling around that, and this concept which is more available to and familiar to people who do developing libraries. That's very funny pain to have to release an npm library each time, and most of the things are automated, generated, and pretty much the logic behind that is a process which is settled down for a while with some deviations. We know that we are able to have a place to discover, to find libraries, to find those versions, to see how that work. And in particular, we do expect when we open a particular page of a library that there will be at least some kind of level of documentation around the package itself. While we are, if to map this in kind of this approach to federated application, like our current stage of the things, we do not expect that application which may federate we'll have releases, we will be able to find the documentation, whatsoever, which obviously makes our life slower to find and test and realize what we are working with. So the build phase is one of the parts of life cycle which has the most variable amount of tooling available for us, and all of them are trying to hit the same goal which we are discussing, is to improve the performance of your build. So there are different approaches, for example, like RSPAC from Webpack, which is kind of Rust implementation of Webpack interfaces, which obviously works several times faster. There are WIT and there are like roll up, roll down. As far as I know, roll down is kind of Rust version, yes build, SVC, and obviously all of the tooling which we are using for build for like decades, struggling to improve the performance of the build in order to reduce the time spent by engineers waiting. So kind of the same goal which we want to achieve here, right? We want to like reduce the time of waiting in between our code change or build into hitting the production. These tools are doing us great help, and in particular, Nix introduces very good and proven concepts which are used by other tools like Bazel and others, of what we can take away in particular practical into implementations which are going to help us to move faster. The bad part about the builders itself that most of them have a different interfaces, and even speaking about model federation, we may have a bit of different configuration or plugins. When we move into federated applications, we lose some great things like reload or HMR server, and there are particular specifics of the builders for framework, libs, CLI, and the platforms. Not going to speak too much about testing using same benefits from tooling like Nix, which has a caching based on if your affected artifacts haven't been changed. The results of tests most likely not going to change too. Unfortunately, to keep in mind that all of those tooling mostly, except Bazel, I suppose, are taking effect the graph of your code, which is available on the local machine, pretty much in one repository. So that works, which works great for one repository, not always great for federated applications, unfortunately, but still gives us a lot of time reduction to move. As for end-to-end testing, situation even worse, because when we are deploying something on the later stages to a particular environment to be tested, or just running that on CI in a Docker, which is kind of a great idea to end-to-end something on environment which doesn't actually matches how that's going to work in production, right? And we run our end-to-end test, and we are already not able to trace back whatever changes we had in code into the stage after deployment when it operates on any environment. So we have to run all of that. And obviously, in order to improve performance of waiting, we do split into smaller application and to modular architecture, whatever. It helps us to chunk the end-to-ends into smaller parts, being able to run only part of it to wait less. So as you could hear me, I'm like repeating a lot of things that in developer experience for us, it makes us wait less to achieve our goal. And our goal is actually to do a code change and make that code change to be delivered on production. In a nutshell, that's what we are paid for, right? Have to mention, and kind of honorable mention for build orchestration tools, which are helping us to achieve those time reductions, not only on local machines, but on CI/CD integration. And particular approaches which are used by those tools are the things which we're going to use for deployment itself, right? In terms of release, things getting a bit funnier because not everybody care about what particular goes into release, especially on smaller applications or smaller teams when they kind of know each other. But for as soon as like larger teams, and we'll speak about like federation and like Micro Frontends kind of conference, and we do understand that the reason to move to federated applications when your like code base is kind of huge, right? And you want to like split it to smaller chunks to be able to iterate faster. That's one of the reasons, obviously, which potentially mean that there are a lot of parallel work and there are a lot of like people who are working on those code bases, and in particular introducing release to your chunks of like features and fixes to make the human able to assign a particular version to know who's responsible for those changes became super important, because that's how you can understand what has changed in between federated applications. So we're speaking about situation when you don't have yet tools in PM like for your federated applications, which is obviously something not super cool. In terms of deployment, we're not going to go into much particular details, but there are a lot of ways to deploy, obviously, which all of them are similar in some sense. But if to highlight one of the important parts for our conversation, so like rolling deployment is when we are gradually updating our environments. Blue-green, when one is available to user, another test and post kind in production. For canary releases, we have a small increment which is available to a small group, pretty much on production too. For A/B testing, obviously we have one kind of couple of more production environments which then shown to user to have to see reaction and actually use monitoring to understand which version to actually evolve later. And a shadow version when it's more used for kind of performance testing, understanding that how a new version behaves. But what most important here in description of all of those deployments, and that I'm not proposing you something which is completely nuts, is in most cases we already have more than one production available at the same time. And that's completely fine. So nothing to shame about that. But unfortunately, in most cases, while we have our kind of fancy Git flow, we have a history, which that was why it was important to bring it back in your memory. Our deployments are still kind of fancy words, which are just an upload of a zip file. Whatever you do, at the like in a nutshell, you are creating a zip file which is uploaded somewhere. In the best case, like Netlify, Vercel, or Cloudflare, you will have a history, linear history of deployments, which has nothing in common with the way how we work. So on one hand, you have a Git flow, which is kind of have a branches, have a history, and participants, and all of those things, which are you get used to how your brain works and perceive the history of your work. And on the other hand, you have a deployment history, which is linear, in the best case, if you have any. And under the hood, whenever we do build, we have our artifacts, and we push those artifacts to a particular deployment environment. We lose the history. We lose the connection in between the changes we did and what is actually served and how that's consumed. So, and whatever zip file we uploaded, it starts to operate somewhere on CDN, on workers, on engine servers. The best things, obviously, which I love, is like when people do Docker builds of static React applications, deploying them to AWS, EC2 servers, whatever, which obviously makes a lot of sense to have it because that became kind of immutable environments, and you have kind of the history of your Docker registry, if any. Whenever stuff is already operating, is available to users, doesn't really matter if it's end user or just like stage environment, whatever, we're already able to collect information, which is important for us about the performance, about error rates. Potentially, if you use a proper continuous deployment or any other approach, even a manual, being able to correlate those metrics to particular versions which have been released to understand how our release, which is a chunk of changes, actually affected our application. To at least have a connection, if you lost a connection between the deploy artifact to a particular code, we still at least should be able to understand that there was a release, which is kind of human readable connection in between, if any, and to trace back. So, taking into account all of the information we have discussed and SDLC, can we deploy under a second? As you can have seen on the live demo, we are definitely able to deploy under a second. And technically speaking, we are not introducing something which is hard or super new, but combined in a bit different combination of things, which allows you to achieve for each build to have a deployment under a second, because let it be Git-like, and kind of, if we speak about deployments, usually like, great, we have to make a clean build with package log on continuous on some CI server in a Docker, to be immutable, to be kind of isolated whatsoever, right? And at the end of that build, we have just files. In particular, we just have it files. And why it's fine to upload just a set of changed files, because that's what Git does for years, and nobody have complained yet that it works. Kind of, it should upload all of everything in my kind of local folder in order to make it work. Now, that's completely fine to have incremental uploads and reconstruct that on a server to reduce engineer time on waiting of uploading those assets. And again, whenever you do a build, you kind of could use an npm-like approach, because you still, in most cases, have some kind of version of your application, maybe in packages, maybe some other place, which is where we can create an increment, kind of a chunk. You did a change. Each change in particular may be counted as a release, and that release may have a version, which is completely fine. That's how, for example, TypeScript works. There are a lot of temporary, I would say, builds, and which was deployed on npm. And if you wish, you can consume the latest from kind of someone else, local or CI build, and that doesn't really break the stuff for anybody. In terms of NX-like, what tools to orchestrate our build process could bring to deployment process is centralized cache. So pretty much, in order to reduce the amount of data, we can say first it's an NX-like or Git-like. The main difference is kind of Git-like is distributed version control, NX-like is more server-oriented, which is what we do. And that allows us to, for your particular application, to see what kind of artifacts we have already for that application and upload only the new one, which reduces the amount of time spent on waiting. And it means that whenever your build is around maybe 10-15 seconds, then you have a deployment under a second, and you have still live reload, even if it's deployed somewhere globally available URL, the way we have seen before in demo. That's kind of an experience where you kind of don't have to change back to local development anymore. You don't have to serve from your local machine on particular setup it, and you can deploy under a second for each build you like. And of course, each time you build, it creates an immutable version. Similar to npm or Git, whenever you do commit, it creates a set of changes which is later on consumed. So can we deploy each build? Why not? So by moving on from current situation, when we have, in best scenario, linear history of deployments, to more Git-like structure, when each commit on each branch, on each commit may have several builds on it while you work. We are moving into structure, which we have the same visualization, and we have our change set, and we have our deployments in the same tree-like structure, which is connected to each other. And we are not losing anymore this connection of what change have triggered something else, because after each deployment, we are having our monitoring enabled and being able to understand how that particular small change, right, like a canary deployments, how that affects our environment or our end users. And based on monitoring, of course, because we can touch a lot of things, follow canary release practice, and because all of the versions are available, they never goes anywhere if they are kind of used. You are able to make benefit of automatic rollbacks based on data from monitoring. Because like, what is the difference in between, like, we are using AI to improve our like coding skills, but why we can't use AI and we're already actually using some kind of AI logic in order to watch for metrics, which is important. Because humans, what we are doing, like, we're doing deployment. Why we don't do deployments on Friday evening? Because we have to watch ourselves for those metrics to understand if things goes correct, if there are any support tickets, if there are something goes down, or if there are like performance drop down, right? So nothing from this list cannot be linked as a stream of data into the service responsible for your deployments, which is meaning that we are able to safely and confidently doing Friday YOLO deployments, as some people most likely who watching me love to do. So for all three questions, we are having yes, yes, and yes. We are able to deploy on every second. We are able to build and deploy each kind of change you do locally. And yes, in a nutshell, if your project manager doesn't know where you live, you are able to deploy on Friday evening, which is kind of a great thing. But this kind of level is available only when we introduce a tooling on a higher order of registration tooling, right? It's like higher order of components consume other functions, and for higher order of registration tooling actually consumes information and is able to use and work on the practices which are available already to us, but combine them and use them together in order to achieve the goal which we want to, right? And our goal and the question we like said initially, can we move at the speed of thought? And I suppose it's obvious the answer is yes. There are kind of not so many tools which are available for higher order. We will like mention one, obviously, where I work at. But important things and takeaways for us, that when it was discussing Git branching, you don't really care where the Git is served, where the Git server is. When you do a new branch, you don't really care how this branch is going to be deployed and served on a Git server, because it works automatically. You do expect it to work like that. You don't really care how npm going to serve your package whenever you publish that, right? So why is any kind of different for our web applications? Why we have to configure each environment if like kind of technology actually allows to achieve infrastructuralness? So whenever we like check out a master branch, we do kind of branch, we do the build, and it's automatically is able to create a new URL and serve our code, serve a new version which we did. Why not? Super effective. And because each version which has been deployed is immutable and has a release and has attached monitoring, we have some kind of a confidence around it, right? We know how that version behaves on a target environment. And that target environment could be any, could be consuming production API, who cares? In terms of the speed, because we are able to kind of skip all of the parts of SDLC, right? Like CI/CD, code review, whatever, and deliver features directly to a place where it's available for production. We are not actually like throwing away SDLC and years of expertise, right? We're just doing that in a parallel in the background. Why we should wait for it to get our stuff working? We don't, right? So it doesn't mean we're gonna like throw in the face of end users whatever we just did locally, but we are potentially can do that already and even run our end-to-end or whatsoever on a production-based API for our tooling which was deployed. And taking the best of NPM and Git tooling in terms of practices which are proven to work for years, and is actually something you expect and your tools to behave like, how that should work. And whenever you work with NPM, you do can do like npm-ls particular version to see how it's used. You can understand what kind of like dependency you have, and like take a look at the other packages and see how it works. And you know the places where it will be, you know the tooling, how that's going to work, and you can go around, discover things internally, maybe find some issues whatsoever. But when you work with federated applications, you don't have such experience, which is kind of very, very disappointing, because in a nutshell, when you have an application, it actually has a name, it has a version, and if you are able to deploy that in a way like npm does releases, right, then you're able to consume that application, not by manually enter at URL, because it's not like an abstraction leak when you have your URL provided to your configuration for local builds. And instead of that, use package.json-like approach to delegate resolution of application name and version resolution into a particular version of the remote application which will be consumed, which on the other hand will be immutable, which allows you to be confident that whatever build you did and deployed, you know that it's going to work whenever it takes. So in the background, all of the things which we are discussing, or most of them, are already working on Zephyr Cloud. Obviously, it's an alpha, and there are a lot of things to be done more, but the core concepts which we have discussed and the demo I have shown is works and operates based on the principles which we discussed, which I hope will become a new, it's not even about like the product itself, but approaches there which allow us to move with the speed of thought. The way how we change the code, deploy it to production, whatever, being able to consume it. Like we get rid of works in my machine, and like we have always uptime, which is kind of great things, and getting our deployments and releases to level of other parts of our life cycle is, right? So what we have for code, for build, for test should be available and should be as a part of our developer experience when we work with deployments, when we work with federation, and things which are not related to performance itself, but most common questions are, it's not platform dependent, so you don't deploy to Zephyr. Think about Zephyr like npm, which helps you to deploy somewhere, and that somewhere could be your own cloud, like Netlify, AWS, GCP, whatsoever. So the main goal here is to bring an experience which is super familiar and expected for any engineer, right? Because those topics are when just fast is not enough for your management. In terms of builder support, there are a lot of samples. So that's not super complicated, but we are a part of the build, so we are context aware and helping to reduce the amount of time spent on waiting. So you don't have to run additional CLI command to be deployed. You just build, and we help you to get it done. So there are other several things which are getting back, like live reload or automated npm-like versions to you, which are a part of Zephyr and going to help you to achieve your, I hopefully, expected level of developer experience for your deployments.
Thank you so much, Dmitry. Thanks a lot for this very interesting talk and showing us how to move at the speed of thought. Unfortunately, we're running a little bit out of time here for questions. Well, and there's one coming in right now. Now they're coming in. It seems like maybe this one, I just saw it here. I just put it on the screen. Is it possible in a monorepo to identify the changed packages to run the CI/CD for based on the imports of the changed files rather than via package JSON dependencies? As far as I know, NX runs as per package JSON dependencies.
Yes, kind of, I suppose. Question, not sure about Zephyr itself or NX, but for NX actually works in monorepos and able to understand, especially if your imports through like tsconfig path is able to understand that. If we speak about Zephyr and federated applications, obviously you have a different, another level, a higher order level of graph of connections from federated applications, which you should be able obviously to run and build.
Perfect. Unfortunately, we have to end here. But if any more questions come up, maybe you could just take a look at the comment section and reply
Sure.
there. That would be great. Perfect. Thanks again, Dmitry, and
Thank you so
enjoy
much
the rest
for
of the
hosting me.
conference.